Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we will discuss some problem related to surface tension. In our previous lecture, we have already discussed regarding the theory part of surface tension. On this lecture, we will discuss some problems related to surface tension. So I have taken some example of this. Now the first question is, the surface tension of water is contact with air at 20 degrees centigrade is 0.0725 Newton per meter. So here the value of surface tension given, surface tension of water given at a temperature of 20 degree given 0.0725 Newton per meter. Okay. And the pressure inside the droplet of water is to be the pressure inside the droplet. Already we have discussed that the droplets will be like this. Okay, so inside this droplet some pressure will be there which will be more than the atmospheric pressure. Okay, and that is to be taken here, pressure of inside the water, that is 0. Or else no need to just we can mention the pressure equal to 0.02 Newton per centimeter square. Okay, and which is greater than the outside pressure. Yeah, as I told you, which is greater than the outside pressure. Calculate the diameter of the droplet of water. Okay, so in the last class we have seen the surface tension for the water droplets. The formula is very simple. P equal to, I think that is 4 sigma by d. Okay, so that 4 sigma by d, here sigma is given already, surface tension of water, and d is we need to calculate pressure given. So this one, this Newton per centimeter square, it is given, we can change it to 0. Into 10 to the power minus 4 Newton per meter square. Okay, so okay, centimeter square given, so we need to convert it into, that will be 10 to the power 4 only, not minus 4, 0.02 into 10 to the power 4 Newton per meter square. Okay, now here we can write d equal to 4 sigma by p value here, what I got here, 0.02 into 10 to the power 4, and sigma value here 0.0725. So we can write d equal to 4 into 0.0725 divided by 0.02 into 10 to the power 4. So that will be nearly equal to, we can get it, so 4 into 0.0725 divided by 0.02, 14.5 divided by 10,000 will be there, so 0.00145. so that is nothing but 0.00145 meter. Okay, that's the diameter of the droplet. You can see how much small it is. It's very small. So we can write otherwise, that will be 1.45 millimeter. Okay, it's very small. Okay, now this is one question. Another question what I have taken here, find the surface tension of in a soap bubble of 40 mm diameter. So here we need to calculate the surface tension of the soap bubble. And what are the data given here? Here diameter given. Previously we supposed to calculate the diameter. Here diameter already given 40 mm. Okay, so that one we can write 40 into 10 to the power minus 3 meter. Okay, and when the inside pressure is given, inside pressure P is given 2.5 Newton per meter square. Okay, so as we know that the surface tension for a soap bubble that is different, and so for that we know the formula P equal to I think it is 8 sigma by d maybe. Yeah, for the droplet it was 4 sigma by d. For soap bubble it is 8 sigma by d. So this is the d. So here we need to calculate the sigma value. So sigma equal to, we can write p into d divided by 8. So it is nothing but p equal to 2.5 into t, how much? 40 into 10 to the power minus 3 divided by 8. So here sigma will be near about, you can say this, make it to 0, 2.5 into 40 divided by 8 and divided by, again we can do 1000. So 0.0125. So 0.0125, that is Newton per 0.0125 Newton per meter. So this is the surface tension of this soap bubble. Okay. So let's see one more problem what I have taken here. So this is the question given, another one, water droplet. So pressure outside droplet of the water of the diameter is given. So diameter is given here 0.04 millimeter, and the pressure droplet, it is given, okay, is, so pressure given is 10.32 Newton per centimeter square. Okay, and this is given atmospheric pressure, P atmospheric. Okay, and calculate the pressure within the droplet. Now here we need to calculate the pressure within the droplet, and if the surface tension is given by is bar has 0.725. So surface tension is given 0.725 Newton per meter of water. Okay, so here what we need to calculate the pressure within the droplet. So what is the pressure inside the droplet, that need to be calculated. So here diameter given, you can see diameter 0.04, that is millimeter given. So you can convert into 0.04 into 10 to the power minus 3 meter. Similarly, this pressure is given Newton per centimeter square. We can convert it into meter square. So 10 to the power, this is 10.32 into 10 to the power, we can write 4 into Newton per meter square. So this is pressure, and we know that formula for this equal to P equal to 4 sigma by D. Okay, P equal to 4 sigma by D. So here we can calculate what we'll get here. Diameter already given, and this P is actually different. Okay, this is atmospheric pressure given. So now we can calculate the value of P here. So that will be 4 into sigma. Sigma how much? 0.725 divided by D. 0.4 into 10 to the power minus 3. I hope. Yeah. Now we can write what we'll get here. 4 into 0.725, 2.9, and divided by 0.4. That's 7.25 divided, we can go 1000. So that is 0.00725. That one you can write in centimeter square. That will be 0.725 Newton per centimeter square. So this is the pressure inside the water droplet will be there. Okay, now actually one outside pressure is there, that is 10.32 into 10 to the power 4 Newton per meter square. So now to calculate the pressure inside the droplet equal to the pressure what we got here, this pressure plus, write down pressure within the droplet, equal to pressure within the droplet equal to what we can write, this pressure plus we can get what is the pressure given here. Okay, So this one we can write in centimeters square, 0.725 plus this is Newton per centimeter square, and already in the question it is given Newton per centimeter square. Same thing we'll consider, 10.32 Newton per centimeter square. So that is the outside pressure, because we know that the inside pressure of the droplet is always greater than the atmospheric pressure will be there. Okay, so what the pressure is there, what we got here, plus this outside pressure, if you add it, then we'll get the value of some near about 11 will get it. So 0.725 plus 10.32, 11.00045, that is Newton per centimeter square. So this is the pressure at the inside the droplet. Okay, because see, directly we got this pressure value, but this is the pressure what we got for the droplets, but it is quite impossible that pressure inside the droplet will be less than the atmospheric pressure. So that's why the atmospheric pressure given as an example, okay, and the pressure inside the droplet will be more than the outside pressure of that area or air, you can say. So that's why this pressure what we got, just to add it on the atmospheric pressure, get the pressure inside the water droplet. So I hope you understood the problem related to the surface tension. These are the small questions are there, objective type questions, or sometimes it may be given 4 to 5 marks, or in the competitive exams it will be given 2 marks question. Okay, so I hope you can easily solve the problem by using these small formulas. So if you are having any doubt regarding this, you can give a comment in the comment box. Thank you all.